Hello everyone, and we are back with the API-20E system this time. Last time we went over enteropleuries. This is another system similar to that gives results for biochemical tests, specifically tests for enteric bacteria, in about a 24-hour turnaround time. Yeah, and we're going to do some labeling. We are once again working with Corynebacterium xerosis, primarily because I know you guys don't have it as one of your unknowns. Now, the API-20E system is slightly different. It's a strip with wells of dehydrated media. What we want to do first is we want to add in some water to our tray here. Just going to go right down the line, adding in water to these small wells. The water is to prevent dehydration of the media when it's in the incubator, especially at higher temperatures. Or in the case of some of our incubators, our more powerfully used incubators tend to dehydrate media rather quickly. Because of that, we want to add in some water to make sure that doesn't happen to our strip. Right. And we're going to put our strip back in the well. Next, we need our bacteria. Unlike with the enteropleury, where we didn't have to use culture techniques, we do for this. And like in the past, you're just going to have to trust me that I am using this aseptically. We're just going to take some of our Corynebacterium, put it in saline, this dip and shake method. All right, now that we have our saline solution made with our bacteria, we are now going to take an eyedropper, sterile, and we're now going to fill up our wells. I'm going to pull out a needle here. If you notice, some of these wells, there's this well here, then there's a cupule on top. For most of these, we are just going to fill the well, with some exceptions. So let's start by filling the wells up. We want to make sure that there's not any air bubbles inside the well. So start there, there, there. Did say there were exceptions. Citrate is one of those exceptions. You can also see that I've put this in improperly. I'm going to have to work that air bubble out. That's going to take some time, so I'm going to finish up the wells, then off camera fix that before we go to the next section. Urea. Same thing with the glucose. I'm going to have to work that one out. Now for this one, gelatin, we're going to top off the cup. Same thing with VP. And I'm going to get to working on the citrate. Citrate we would also cap off. And I'll also get to working on the one over here. There's one over here that I have to work on as well. Here it goes. Glucose is done. And we're back. It's been a couple minutes for me, probably only a few seconds for you. Now, unlike the others, we do have to add in something else as well. We're going to take another of our sterile pipetters. And we are going to add in mineral oil to a few of these. Wells 2, 3, 4, 6, and 7. Okay? So, pop this off. Grab our mineral oil. Make sure all the bubbles go up towards the top. And we'll go through and add mineral oil to the cupule section of each of these. Remember, it's 2, 3, 4, 6, and 7. Okay. Now, other ways of making this easy, or at the very least making things easier to see, we can always do what I'm going to add in here, which is, this is Corynebacterium xerosis at 37 degrees as a means of, once again, making sure, just in case up here where this is, isn't fully seen. We are then going to take our lid, which I have off to the side here, and incubate this at 37 degrees for 24 hours. There is another form of this system called the API Rapid, which instead of being a 20E, it's a Rapid 20E. It has a different set of tests, a different battery of tests, but it only has a 4-hour turnover time. Same as before, if we take a look at our key on page 573. Not much changed. There was a little bit of glucose, a little bit of ARA. But aside from that, everything else appears to be negative. So what can we do with this? Well, we're going to start off by taking a look at this and adding in a few things. First, once again, with our VP, we're going to add in our Vogue's Pro Scour reagents, which are Barrett's A and Barrett's B. So we're going to start with Barrett's A. Now, Barrett's A is potassium hydroxide, and Barrett's B is alpha naphthol. Barrett's B. Next thing we're going to move to is TDA well, which stands for tryptophan deaminase. Which is this well right here. And for this, we're going to need ferric chloride. Now, that is a negative. It's a yellowish color for TDA. A positive would be a brownish red color. And the last one we have is nitrate reduction, which is going to be done inside the glucose tube. Now, for this one, I am going to pull out a Sharpie. And we need to take a look at the glucose tube to start off with, see if there's any gas. Then I like to label it with A, B, and then Z. And I'll say why we have Z in a minute. But let's start with A. We're going to need nitrate A. Now for this, we wait for 2 to 5 minutes to see what happens. Now we are back, and as you can tell up here from our VP test, that is a positive VP test. It's sort of reddish brown color, and then down below being a yellowish color. So now that we're back, we're going to take a look at this and add in, since we've added in our A here, I'm going to mark down this. This is a negative. Our B. And let's add in nitrate B. Here's our nitrate B. And we let this sit for 5 minutes. While we wait for the nitrate to finish up, we are going to take some of Kovacs reagent, and we are going to add this to the indole well, the IND well. Let's see if this is indole positive. Okay, so now we've waited for around 5 minutes. You can see that our glucose here is still negative, so we're going to confirm that using nitrate C. Just going to take a small amount of zinc on a spatula. Place it right there. And now we let this sit for around 5 minutes with the knowledge that if this were to turn a pinkish yellow color, it would be a negative, but if it stays this yellow color, it's a positive. We are back after 5 minutes, and as you can see, there isn't really much of a pinkish color to our glucose tube. It's even at the top where the zinc was, it's still a yellowish color. So that would be positive. And here's what our full strip looks like after zinc. And I'm just going to put a Z down here so you know that it took zinc to get that far. And that is our API strip.